Okay, so hi guys, I was confused about example 6 from section 5.3 and I just want to go over that again, okay? So what we have right here, for the two eigenvalues you see, lambda equals 5 and lambda equals minus 3, they found the corresponding basis vectors for the eigenspaces, okay? So for the lambda equals 5 eigenspace, they found these two basis vectors, and for lambda equals minus 3 eigenspace, for the lambda equals minus 3 eigenspace, they found these two eigen or basis vectors. Okay, keep in mind that these basis vectors correspond to free variables. Okay, that's a important idea. So what they say is that you can justify the linear independence of all this by theorem 7. So let's go back to theorem 7. The key is this sentence right here. The matrix A is diagonalizable if and only if the sum of the dimensions of the eigenspaces equals n. Okay, so first let's figure out what n is. Well, because A was a 4x4 matrix, n equals 4, okay? Now, the dimension of because an eigenspace is really a null space, the dimension of a null space is the number of free variables in the echelon form, and because we know that these basis vectors correspond to free variables, the dimension of the eigenspace here is 2, okay? The dimension of the eigenspace here is also 2, and 2 plus 2 is 4, so therefore this condition right here is satisfied. The matrix A is diagonalizable if and only if the sum of the dimensions of the eigenspaces equals n. So that condition is satisfied. So now let's go back to theorem 5 for a minute, if that's okay. What does it say right here? An m by n matrix is diagonalizable if and only if A has n linearly independent eigenvectors, okay? So theorem 7 just proves that A is diagonalizable because of that condition, and what theorem 5 says is A is diagonalizable if and only if A has n linearly independent eigenvectors, okay? So in reality, the book has it wrong right here. The book has it wrong right here. It's theorem 7 that proves that A is diagonalizable, but it's actually theorem 5 that proves that this set right here is linearly independent, okay? And then the rest of this is just finding P and D. I hope that was helpful. I highly suggest that you reread theorem 5 and theorem 7 again and really think about them, because theorem 5 and theorem 7 are extremely tricky and it takes a while for the intuition to come. You're not going to get intuition by just watching my videos or just passively reading the words in your mind, okay? You have to read it today and then come back to the theorem tomorrow and keep on refreshing until you get it, okay? Because it's going to take a while, but the videos are going to help. And I can't conclusively know whether you're understanding this or not, so if I'm doing a bad job, I really wish you could, I really hope that you'll send me a comment or something, and I'll try to fix my teaching to your preferences, okay? I'm going to go now. I'm going to go over the true or false in the next section.